Poop. It's everywhere and everyone does it, but it's often discarded off or put on the fields as a fertilizer. But could it also be a valuable and renewable resource as a filler in 3D printing filament? That's something I wanted to know for ages, so I mixed cow dung into PLA 3D printing filament to see if we can print with it, how strong it is, and of course, how it smells. So follow me on this interesting journey that isn't as gross as you might think. Let's make some PLA. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. We'll talk a lot about cow poop in this video, but something you don't want to look like crap is your website. And that's exactly where today's sponsor Squarespace comes in. Squarespace is hands down the best place to go if you want a professionally looking website. I've actually been using them for years for my own site, and honestly, it's just simple. Making a web presence that looks great can sound intimidating, but Squarespace makes it super simple. You can start with one of their beautiful templates and customize that to however you like it. Or you can try out their new Blueprint AI, which actually builds a unique site layout for you just by answering a few quick questions. You get a finished site in minutes, and the best thing is it will always look great, regardless on desktop or on your phone. You should give it a try yourself and play around with their website editor totally free. Just go to squarespace.com/CNCKitchen. Want to add a shop to sell your products? A blog to share your projects? Even online courses where you can teach your expertise. It's all there. Squarespace is super easy to use, but also surprisingly powerful and scalable. So it doesn't matter if you're a maker selling STLs, an artist presenting a portfolio, or a business needing a professional website. So if you want to give it a try, just head to squarespace.com/CNCKitchen for a free trial, and when you're ready to launch, use code CNCKitchen to save 10% on your first website or domain purchase. Huge thanks to Squarespace for supporting my channel and helping me bring my wildest ideas to life. Back to our PLA. This might sound literally like a shitty idea, but please hear me out. Fillers are a widely used thing in plastics. You have the reinforcing fillers like carbon fiber that make the material stronger, and the non-reinforcing ones that are usually added to mainly reduce costs and replace parts of an expensive polymer with something that is cheap just to add volume. If you have a 3D printer, you've probably heard of wood filament, which is usually PLA mixed with wood dust that gives the printed part a very nice look and feel and smells really nice during printing. Speaking of smell, not every poop is alike, and I think it would be a horrible idea to add, for example, our chicken manure or even human poop to filament. Yet cow dung is different, because we have herds of happy grass-fed cows around here where their poop should mainly be the undigested fibers of the grass that they ate. And if it's fresh, it doesn't even smell that bad, and you can already see the fibers embedded in the patties. I initially wanted to do this as a theme project a year ago for OpenSauce when it took place in the Cow Palace near San Francisco, but I didn't get around doing it at that time. OpenSauce is the greatest maker and creator event, and it's happening again in only a week on July 18th to the 20th. And I can only highly recommend coming if you can. I'll of course be there. And even though it's in San Mateo this year and not in the Cow Palace, I still wanted to find out if cow poop might make the 3D printing filament of tomorrow. So I drove to a nearby field, admired the beautiful sunset, and gathered some mostly dry cow droppings that were probably from the day before. I live in an area where some of the best cheese is made, so we have a lot of dairy farming around here, and many of the cows freely graze on the fields and constantly eat fresh grass with a high fiber content. I mean, it has a bit of a smell to it, but especially if it's not that old, dried quickly, and didn't start fermenting, it's really not too bad. So I brought the cow patties back to the studio, where I needed to make a fine powder out of them that we can mix with PLA and extrude filament from. The poop wasn't completely dry and should also be sterilized first. So I put it into a stainless steel tray and placed it in my drying oven overnight to drive all of the moisture out. My studio colleagues were a bit worried that the whole place would smell horribly during the project, but in the end confirmed that it wasn't as bad.
Es hat irgendwie was Frisches aus dem Backofen.
Jetzt hat so ein bisschen was von Misthaufen, aber nicht so schlimm.
The 18 hours in the oven were able to fully dry everything out and make them hard like a brick. and this was the perfect condition to start pulverizing them. I bought a coffee grinder especially for this reason a while ago, so I broke the patties into smaller pieces, and within only a couple of seconds on the grinder, the blades turned everything into fairly fine powder. Ooh, poop smoke.
Don't breathe this.
One of the big challenges when making things that go into filament is that a 3D printer nozzle is pretty small. In most cases 0.4 millimeters to be precise. So if I compounded the ground up material directly into PLA, there would be a high chance that it would clog the nozzle. And just one particle that is too big could make everything fail. After learning that the hard way when I made coffee filament years ago, I started by sieving the material. In my case, I used a 60 mesh sieve, which has an opening size of 0.25 millimeters. That's still on the bigger side for such small nozzles, but it was the only thing I had at that point. And by looking at the amount of material that stayed in the sieve, it was obvious that a lot of the material didn't meet the size criterion. So I took that, put it back into the coffee grinder and blended it another time to get a bit more material out until I thought I had enough for a first run. It's really interesting to look at the fibers under a microscope because you can see a fascinating mix of very fine material along with some of the old grass fibers. When measured, it's interesting to find that they are sometimes over a millimeter long, but their width usually falls within the 0.25 millimeter mesh size of the sieve. This shouldn't be a problem for printing because these short fibers typically align with the flow of the material, so even something that is longer should go through the nozzle in the end. When making filament, it's very important that everything is super dry, because you don't want any steam forming within the process, which could not only generate foam, but also hydrolyze the material and rip polymer chains apart, making the filament brittle. So I put the poop powder into a tray, selected the proper program on my toaster oven, and put it in there for a few more hours. Once it was almost completely dry, I started preparing the filament extruder. For this experiment, I'll be using the Artme 3D Mark III S Plus DIY filament extruder. It still costs 900 euros, but it's probably one of the most affordable and what I would say maker grade extruders that can produce really nice looking filament. Before I could extrude the cow dung filled filament, I had to preheat the units to 170 degrees Celsius, and once it reached that temperature, I purged out the old material that was still in the barrel. While it was preheating, I first installed an empty spool on the winder, and then got my poop powder out of the oven and prepared the first mix. I first added the PLA pellets, but how much poop should and can we even add? Even though it would be nice if we could replace a lot of the plastic, the more fibers we add, the more difficult extrusion and also printing will be. So for my tests, I thought it was a good idea to start with a low mixing ratio. I weighed 150 grams of freshly dried PLA pellets and added 7.5 grams, so 5% of our poop powder. In order to make sure that everything was evenly distributed, I closed the lid and mixed it all up. When I opened the lid, you could clearly see that the powder had nicely coated the pellets with barely any excess in the container. So I took the mix and poured everything into the hopper of the extruder. At first the material still extruded clear, but it didn't take long until the first fibers made it through the melt zone. Since everything looked really consistent, I didn't hesitate too long and started the winding process. To do that, I cut the still soft filament with scissors, threaded it through the position sensor and inserted it into the feeder that moves the filament to the winder while making sure to keep constant tension. The latest version of the Artme 3D extruder now also has an analog diameter sensor, but I still cross-checked the dimensions with a caliper. Once that looked good, I went to winding. So I tried to feed the end of the filament through a hole on the spool to start pulling. Unfortunately, that wasn't super easy and the filament snapped right away. To reduce the bend radius, I directly taped the end of the filament to the core of the spool. And that did the trick, at least for a short time. I had the feeling that the material was super brittle, but at only 5% fibers added, that seemed a little strange. To at least spool a bit more material, I removed the empty spool and added a spool that was half full. That way the bend radius of the filament was smaller and should reduce the risk of breaking. And that seemed to do the trick. It was really nice to see how the fibers mixed into the PLA. And since it wasn't all just bigger fibers, but also smaller particles, lignin, proteins and even some minerals, the addition of the cow dung also added color to the filament into what I would describe as a brown, yellow, greenish color that matched the theme of the material pretty well. Even though there is a mixer attached to the screw of the extruder to help feed the pellets, I didn't have the impression that it caused an unmixing of the PLA pellets and the dried filler. Even after several minutes of extrusion, the powder still nicely and evenly coated the outside of the beads. Unfortunately, I was a bit overconfident with my solution to my breaking filament problem, because after some minutes the filament snapped again and caused everything that I had already spooled to unwind. So I gave up on the spooling idea for now and simply let the rest of the filament fall onto the floor. When the filament in the feeder got lower, I also noticed another issue. Even though the plastic pellets still seemed evenly coated, some of the powder did actually separate and collect at the bottom. This got so bad that when I was almost finished with the mix, almost all that was left was the cow dung powder, which then also fed into the screw extruder and resulted in it completely clogging. I vacuumed out the rest of the material to make sure that no more filler was dragged into the extruder, and when I wasn't even able to clear the clogged nozzle with our nozzle pokers, I ultimately had to unscrew the nozzle and let the rest of the material purge out with new PLA pellets I fed from the top. Initially, the mix really foamed up once it left the extruder, but when all the clean PLA pellets finally purged everything out, the material was nice and clean again. Even though I didn't have a lot of material in a continuous filament, I thought I'd give it a try and see if and how it prints. From my previous experience with making coffee filament, I knew about the risk of clogging small nozzles, so I started with the 0.8mm one and thought I'd work my way down. I printed everything on my old Prusa Mark III because it still has the Revo nozzle change system on it, and I also had the large nozzles at hand. The 0.8mm Banshee printed easily. It was a bit stringy, but that was to be expected with the bigger nozzle and an untuned profile. It didn't finish all the way because I ran out of material at some point, but the results were pretty respectable, and the print had a really nice green goldenish tint. A big question is probably the smell during printing. First of all, it doesn't smell nasty or like cow dung. I would describe the smell as grassy, similar to throwing a bit of fresh grass into a campfire, but not unpleasant, but still not as nice as some wood filaments that I printed in the past. The printed parts and also the filament were odorless, by the way. With that burning question out of the way, I went to the 0.6mm nozzle, and that also printed well at first until the filament broke in the Bowden tube and left me with only part of a board. But up to that point, the results looked respectable, and I was also nicely able to spot how the fibers within the material aligned with the printing direction. After the filament snapped again, I took a closer look at the filament to find out what the reason for this brittleness could be. Even though a meter of material could look really well, I found these regular inclusions, or rather agglomerations of cow dung in the filament. And since at these locations there was almost no plastic left over, the filament became super brittle and of course broke even at low bending angles. This means that our cow poop filler doesn't properly mix with the PLA during extrusion. To be honest, it already mixes way better than I expected. You see, industrial extruders are not only way longer, giving pigments or fillers even more time to mix into the material. When fibers are mixed into plastics, this is usually even not done on regular single screw extruders, because they simply don't mix the material so well. In these cases, twin screw compounders are usually used. They mix plastic and filler almost as you would knead dough, resulting in a very even distribution of fibers in the polymer matrix. Since I don't have a compounder, I had to find a different solution because I wanted to get this working. Not only to finish this video, but also to have a process in the future to mix other things into 3D printing filament, like bacon, hemp, or maybe even thermite? What do you think? The first thing that came to my mind was simply re-extruding the filament that had the inclusions. So I planned to chop up the material into small chunks and then simply put them into the hopper of the extruder and make new filament. The idea here was that this should not only make the distribution of the material more equal, but as I hoped, it would also break up the agglomerations and distribute them as well. So I got my old filament pelletizer, which is basically a wood drill into which I feed my filament at the right speed so that I pelletize the material. I gathered all the filament chunks I had previously made and chopped them up one by one, which took a bit of time, but in the end I was left with a good amount of poop PLA pellets to process further. I put everything in the oven again for a few hours to drive the moisture out and then poured it all into the hopper for a second round of extrusion. Once everything came out of the nozzle evenly, it was time for spooling and the filament already felt way better. I was easily able to start spooling and the filament wound up really nicely. The other thing that was interesting to see was that even though it was the same material, the color became darker. I can imagine that this was due to the caramelization of the sugars that were still left in the cow poop. My pelletized material fed great, and also the diameter came out almost perfectly. I got a good amount of filament onto the spool and thought that I had finally tackled the problem when it snapped again. Looking at the fracture surface showed that the reason again was an agglomeration of fibers that didn't properly mix within the screw extruder. So even though the filament was already of way better quality, it wasn't perfect. And just one of these agglomerates within the filament can potentially ruin a whole print, which doesn't make them acceptable. But I had one last ace up my sleeve. You see, this simple screw extruder isn't properly able to mix our fiber filler with the molten plastic. So we need to make sure that everything is already properly mixed before it goes into the extruder. The powder adhered mostly well to the pellets, but some of it shook loose. And if you look at it properly, the volume of the pellets and the filler is still very unevenly mixed. So how do we improve that? This right here is microplastic, or let's better say, this is PLA powder with a significantly higher surface area than our PLA pellets. And this might allow us to evenly mix both components before they go into the extruder to completely get rid of our agglomeration problem. I first tried everything and then created another mix, 150 grams of PLA powder and 7.5 grams of our sift cow dung. After shaking it a little, I was already able to see that the mixing was way better and I had a very finely distributed filler between the PLA. So I loaded it into the hopper and started extrusion. After the old material was purged out, I quickly got a very good looking filament that I directly started winding. After the diameter looked good, I connected the end to the spool and it started filling the roll. At first glance, I didn't see any agglomerations in the material and the filament seemed to have a very even distribution of particles in it. It also was by far not as brittle anymore as the last batch and formed a really nice wind. Unfortunately, after about half of the material was extruded, I started noticing that the diameter fluctuated quite a bit and also the color of the material changed from a dark brown to a lighter hue. This quickly became worse and I realized that the filament was actually foaming up once it left the nozzle. I'm still not sure about the reason behind this. It could have been moisture, but since the material was only out for half an hour, it doesn't seem super likely. I rather think that I had a feeding problem, because the fine PLA particles don't flow as well as the pellets did, which resulted in inconsistent material flow and therefore also inconsistent pressure within the extruder. If you have more experience than I do, please let me know, because this wasn't the only time I had this problem here. I still ended up with a nice sample of cow dung PLA that looked much better than my previous batches. If we put the first 3 attempts side by side, we can see something very interesting. The PLA from pellets had the lightest color and was still a bit transparent. The re-extruded filament was already darker, and I previously suspected that the sugars caramelized. Yet the filament made from the PLA powder was actually even darker, which hints that the change in color is simply due to a better distribution of the particles within the filament. Pretty impressive, to be honest. Since the filament looked so uniform, I thought I'd go all the way and print a 3D Benchy with it using a standard 0.4mm nozzle. And this, to my surprise, worked remarkably well. The filament printed without any problems and at an amazing level of quality. You could even argue that you were able to see the reinforcement effect, because I was missing the typical bowline that results from the shrinkage of the material during printing. We'll see if the fibers really enforce the material when we later test and compare its strength. After this reassuring success, I made another batch and this time added 10% cow dung by weight into the material, and even this extruded surprisingly well. Spooling it wasn't a problem, even on the normal small diameter of an empty spool. The only problem I again encountered was that after half or 2/3 of the material went through the extruder, the filament started foaming again, ruining the rest that was still left over. Yet I had plenty for a 3D Benchy, which again looked amazing when printed on a regular 0.4mm nozzle. I wanted to find out a limit, so I made a material with 15% cow dung added. The two materials again mixed very evenly in the bucket, and the extrusion went smoothly until I encountered the foaming problem again, despite regularly tapping on the hopper. I really want to know where this is coming from. Since the printed board still looked amazing, and besides foaming, everything went well. So I did my final batch at 20% cow poop by weight, which, just looking at the ratio in the bucket, is quite a bit. Besides having a substantial amount of poop in my material, the extrusion went great until it foamed up again, but it left me again with enough material for a benchy and later my test parts. The texture of the print looked expectedly even a little bit rougher than previously, but it printed great even through the fine nozzle. The print results with the material made from PLA powder really impressed me and showed that if I worked with pulverized plastic, I can now even experiment with different compounds on my inexpensive filament maker. Looking back at the first print results showed that the color intensified from the 5% to the 20% cow dung content and the surface roughened. If we look at the print through a microscope, we can also see how the fibers are very nicely embedded in the material, giving it that unique look and feel. But the thing that I was naturally asking myself was if the fibers also reinforce my PLA prints. So would the new cool material be poop fiber PLA instead of carbon fiber PLA? For this, I first extruded some unfilled PLA from my PLA powder as a reference material so that we know how strong the parts would be without any fibers. Then I printed my good old test hook, once standing and once flat on the bed. That worked very well for the natural PLA, as well as the 5 and 10% variants. Unfortunately, I couldn't get the standing samples of the 15% and the 20% poop PLA to print, because the filament always jammed at some point. I'm pretty sure that the nozzle didn't clog, but I rather had some heat creep jam, because I printed the parts during a big heat wave here and had almost 30 degrees Celsius in the studio, and also all the benchies before did print great. If you're, by the way, wondering whether such a fiber material can damage your nozzle, I printed about 100 grams of PLA through our CNC Kitchen unleaded brass nozzles, and it lost 200th of a millimeter in length. That's not a lot, but after such a small amount of material, does suggest that cow dung fibers can potentially damage your nozzles if they're not made from hardened steel. But back to the strength tests. I still went ahead and tested the parts that printed on my DIY tensile tester. Let's start with the reference, where the hook that was printed flat failed at 671 newtons and the standing one printed at 337 newtons, which is a layer adhesion ratio of 50%, which is on the low side for PLA, but acceptable. The horizontal hook with 5% cow dung failed at 535 newtons, which is only 80% of the reference, and the layer adhesion also dropped to 37%. This trend continued for the other hooks, ending with the 20% filled one failing at only half the strength of the reference. You could argue that putting cow dung into 3D printing filament unfortunately doesn't improve the strength of your parts, at least at the particle size and ratios that I use. Some might say that this is a bummer, but even many carbon or glass fiber reinforced materials don't add significant strength. They primarily increase stiffness and improve properties like dimensional accuracy, or simply make the parts look nicer. And I think I also achieved the last 2 points with my PLA. Getting rid or at least reducing the bowline on the benchy indicates that the material shrank less during printing, and the look and feel of the parts are really nice. Again, using in my case up to 20% less plastic because it was replaced by cow poop. And if you're worried about odors, the parts don't smell a single bit. Everything was sanitized during drying and extrusion, and the fibers are perfectly embedded into the polymer matrix. For me, all of this was a great learning experience, and successfully embedding particles in PLA with really cheap DIY equipment opens up many possibilities for the future. So, Coffee PLA version 2 is definitely on the way, and I have more ideas on my list as well. If you have some, put them down into the comments. Whether manufacturers will now start releasing cow poop filament is something I'm not really sure of. I mean, cow dung is definitely a renewable and arguably interesting resource. But even though it is, in my opinion, one of the least gross poops, I'm quite sure not everyone is going to be okay with this waste product in their filament, even though it can save significant amount of plastic. So this question is now up to you. Would you buy PLA, or do you think that this is the worst idea that you've ever heard? Roast me down in the comments. Thanks for watching everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye. Of poop PLA pellets to process further. P.